Let's discuss the question. A 65 kg boy, a 65 kg boy sitting on a sled on frictionless snow. Okay. After discussing the question, we can understand uh, there is a sled like that. Okay, and a 65 kg boy sitting on this sled sitting on this sled 65 kg boy sitting on this sled. Okay, like that, on a frictionless snow. That means the friction between surface and this sled, the friction between this surface and this sled is zero. Okay, friction between surface and this sled is zero, so that means this surface is frictionless. Okay, throws a 0.05 kg snowball. Throws a 0.05 kg snowball. There is a snowball like that. There is a snowball like that. Okay, let's draw a snowball with different color. Let's draw a snowball with different color. Okay, there is a snowball like that. Okay, this is a snowball. Okay, he throws a snowball which has mass 0.05 0.045 kg 0.045 kg snowball forward with a ground speed of 30 meter per second. He throws a ball and this snowball moving with the velocity of 30 meter per second with respect to ground. Snowball moves after throw the snowball by the boy. The snowball moves with the speed of 30 meter per second with respect to the ground. That means in ground frame, ball move with velocity 30 meter per second after throwing the ball from the boy. Okay. Next, if the boy and the snowball are initially moving forward with the speed of 2.5 meter per second. Basically, initially, that means, let's suppose this is initial state. Let's suppose this is initial state. At initial stage, both slide and snowball and boy, both are moving with initial velocity 2.5 meter per second. Initially, both of them move with velocity 2.5 meter per second. 2.5 meter per second before the snowball is thrown. What is the velocity of the boy after he throws the snowball? What is the velocity of the boy after throws the ball? After throw the snowball by the boy. Basically, we know that after throws the ball by the boy, ball move with velocity what? Ball move with velocity 30 meter per second. Okay. Basically, if we in the final stage we can see that in the final stage we can see that it's like that. This is a slide and this is a boy. Okay, this is a boy, and let's suppose boy and this sled after throwing the ball. That means he throws a ball in this direction, so ball moves is like that way. Okay, ball is moving in like is like that way. Ball moves in like that way. So ball move with velocity after thrown by the boy. Ball is moving after thrown by the ball is nothing but 30 meter per second with respect to ground. 30 meter per second with respect to ground. And let's suppose after throwing the ball, boy move with velocity, let's suppose v. Boy move with velocity v. Okay, so this is the question scenario. Okay, v, what is v here? V is equals to velocity of boy plus sled. Velocity of boy plus sled after throwing the ball. Velocity of boy plus sled after throwing the ball. and this is with respect to ground, in ground frame. In, let's suppose in ground frame. Okay, now what is the next thing? We should calculate what is the velocity of the boy after he throws the ball. Our purpose is to calculate v. Our purpose is to calculate v. Basically, if we see the question, we can see that there is a frictionless surface, so there is no frictional force between the sled and the ground. So there is no frictional force, or there is no external force present in this system. Boy, ball and sled. There is no boy, ball, sled plus ground. In all these four things, boy, ball, sled and ground, there is no external force present. है ना? We can see that there is no external force present between, there is no external force present in the system including in the system including system, what things system include? Boy, ball, sled and ground, including boy, ball, snowball, boy or snowball or sled and ground. There is no external force present in the system including boy, snowball, sled, ground. Okay, there is no external force when boy throws snowball. We can see that when boy throws a snowball, there is no external force present between boy, ball, sled and ground. Okay, we can see easily this type of thing here. Okay, done. Now we know that if there is no external force present in the system, if there is no external force present in the system, the momentum of the system should be conserved. We can also say that if no external force present in the system, so momentum of the system should be conserved. Momentum of the system should be conserved. Okay. If no external force present in the system, so momentum of the system should be conserved. Okay. Done. That means initial momentum is equals to final momentum. Or we know that what is the formula of momentum? Momentum, which is denoted by P. Momentum, which is denoted by P, is nothing but mass into velocity. We know that. We know about that momentum formula. What is the momentum formula? Mass into velocity. Okay. So, if no external force present in the system, so momentum of the system should be conserved. That means initial momentum is equals to final. What is the initial momentum of the system? Mass of the system multiplied by multiply by velocity. Velocity, what is the initial velocity of the system? What is the initial velocity of the, okay, we can take mass of the system, mass of the system multiply by velocity of, initial velocity of the system, equals to, what is the final momentum? Final momentum, if we see that final momentum include two objects, one is ball and other is boy. So boy move with velocity v and ball move with velocity 30 meter per second. So in final momentum there are two objects and both objects have different momentum. So what is the momentum of this object? That means boy is nothing but mass of boy plus mass of boy multiplied by velocity of boy. This v is equals to velocity of boy plus lead after throwing the ball in ground frame. Okay, this is nothing but boy, mass of boy with multiplied by velocity v. Mass of boy multiplied by velocity v. Mass of boy multiplied by velocity v. V is the velocity of a boy plus lead after throwing the ball, which we have to calculate. And what is the momentum of this ball? Which is nothing but mass of the snowball. Mass of the snowball. We can write like that. Mass of the snowball. Mass of the snowball multiplied by velocity of this ball, which is nothing but 30 meter per second. We can write like that. And we know that initial system has velocity is nothing but 2.5 meter per second. We can write like that. So what is the initial momentum? Initial momentum is equals to mass of the system multiplied by velocity of the system, which is nothing but mass into 2.5 meter per second. Similarly, final momentum is nothing but combination of two objects momentum. First object momentum is nothing but mass of the boy multiplied by velocity of the boy, which we consider v. Okay, multiply plus mass of the momentum of this ball is nothing but mass of the snowball multiplied by 30. So put the value of mass given in the question. Okay, so what is the mass of the boy? 65 kg. Boy sitting on a sled on frictionless snow throws a 0.05 kg. So this is the mass of the ball and this is the mass of the boy. So what is the mass of the boy? 65 kg. This is the combined mass of the system, which includes boy as well as ball. So what is the boy mass? 65 kg plus what is the ball mass is nothing but 0.045 kg. So this is the mass of the system. Okay, multiplied by 2.5 meter per second is the velocity. Then this is the combined mass of the system multiplied by velocity of initial velocity of the system is equals to mass of the ball. What is the mass of the ball here? Mass of the ball is nothing but 0.0. Mass of the ball is nothing but, sorry, this is the mass of the boy. This is the mass of the boy. What is the mass of the boy? Mass of the boy is nothing but 65 kg multiplied by velocity of the boy after throwing the ball, which we have to calculate is nothing but v, plus mass of the snowball. What is the mass of the snowball? 0.0545 kg. 0.045 kg, which we multiply by velocity of ball after throwing by the boy, which is nothing but 30. Okay, now calculate these things, which we calculate these things. 65.045 multiplied by 2.5 is equals to 65v plus, if we calculate we can get 45 because 0.45 we get plus 0.045 multiply by 30. Okay, done. Now after solving this, now we solve this question here, calculation. We know that what is the calculation of this? What is the calculation of this? Okay. Calculate these values. After adding multiply by 2. This digit with 2.5, we get 65.045 multiply by 2.5. Calculate this. 50902 11 5416 233 616 2610. And if we use decimals place 1 2 3 4, that means decimal place comes after 4 digits. Then what is the value we get after multiplying by both these digits? Is nothing but 162.6105. 16 we get 162.6105. Okay. Okay, and after this is 65V. Okay, this is nothing but 65V. Okay, plus after calculating these things 0.45 multiplied by 30. This is nothing but 0.45 multiplied by 3. Okay, 0.453. 3 5s are 15. 1 3 4s are 12, 13. So this is nothing, comes out 1.35. This is nothing but 1.35. This is nothing but 1.35. Okay. Done. Now after this, this 1.35 move towards left hand side and 65 move towards denominator side. Okay, see here, after calculating this, we can write 162.6105 minus 1.35 equals to V divided by 65. Okay. After solving these numeric value, let's solve these numerical value. Okay, let's solve these numerical values. Nothing but 162.6105 1.3500. Okay, let's solve this. 5 9 5 1 1 6 1. Okay, we get that. And this whole term 161.1595 divided by 65 So let's after calculating these numeric values, we get 2.4793. Okay, done. So after calculating these three values, we get V is equals to nothing but 2.4793. So this is velocity of the meter per second. This is velocity of the, this is nothing but velocity of the, boy after throwing the ball. This is nothing but velocity of the boy after throwing the, ball. Okay, let's remove this rough work. Okay, this is the 2.4793 meter per second. This is the velocity of the boy after throwing the ball. Okay, that means v is equals to nothing but we get this value. Okay, this is our solution of the question.